Hi everybody, my name is Peter Garwango from MUK Science Turing Center. Welcome to our second section in organic chemistry. Today we are discussing how alcohols can be substituted using different reagents, and in today's objectives we are going to see how phosphorus trihalides and the sulfonyl dihalides in presence of a pyridine can be used in reactions with alcohols. So the general reaction with alcohols will be ROH plus PX3 in presence of a pyridine to give us RX plus POX2 as our products. So now we are going to see how primary, secondary, and tertiary alcohols react with these reagents. So to begin with the primary alcohol, let us use ethanol as CH3CH2OH reacting with phosphorus tribromide So now oxygen has a lone pair of electron which attacks the phosphorus, and one of the Br bonds break off, and we shall have CH3 CH2OH to the PBr2. So our oxygen gets a positive charge, and therefore this is a beta leaving group. So the Br minus will come and do a backside attack on this carbon, and our pyridine will come and attack this hydrogen, and this bond will break off in favor of the oxygen. Then we shall form bromoethane as our major product plus POBr2. So this is our product when primary alcohols react with a phosphorus tribromide in presence of a pyridine. So now what if you have more than an alcohol that has a primary alcohol that has more than 3 carbons? Let us see how that affects our major product. So now in this case we shall use propanol, which is CH3CH2OH reacting with phosphorus trichloride. So now the same mechanism, the lone pairs of electrons on oxygen will attack the phosphorus, and one of the chlorine atoms breaks off to form CH3 CH2 CH2OH to the PCl2 with a positive charge on the oxygen. Again, the pyridine will come for the hydrogen, and this bond will break off in favor of the oxygen. But when this bond gets off, this carbon will get a positive charge, so it will be a primary carbocation which is unstable. So therefore on this step we shall have what we call a hydrogen shift. A hydrogen from this carbon will shift to this carbon, and then the partial positive, the carbocation will be transferred to this other carbon in the middle. Hence we shall have a resultant species which looks like this. So therefore this is a secondary carbocation more stable than the primary carbocation we would have formed in this step. So this is when our chloride ion attacks this species, then we form our final product as CH3 CHCl and the CH3. So now this is our major product when an alcohol that has more than 3 carbons reacts with a phosphorus trichloride in presence of a pyridine. So now let us jump into the second objective, which is how secondary alcohols are going to react with the same phosphorus trihalide. So in this case, I will use cyclopentanol, 2-methylcyclopentanol reacting with phosphorus triiodide. So again, oxygen has a lone pair of electron, binds to the phosphorus, one of the iodine atoms breaks off, then we shall form OHP O2. So now this is going to be our intermediate species, very high energy molecule, and in this case, still, since this is a secondary, it was a secondary alcohol, it will form a secondary carbocation on this carbon when this bond breaks off. But since we have a methyl group on this carbon, formation of a carbocation on this carbon gives us a tertiary carbocation, which is more stable than a secondary. So therefore, we shall have a hydrogen shift. So this hydrogen from this carbon will shift to this other carbon, and the carbocation will shift to this carbon with the methyl group. So again, we shall have a hydrogen shift, and then our resultant carbocation will be on this other carbon. And this is when our iron comes in and attacks this carbon and gives us our final product as so this is our final product when our cyclopentanol, 2-methylcyclopentanol reacts with phosphorus trihalide in presence of a pyridine. So here I forgot to show you a pyridine, which is the base. It takes the hydrogen out. So this is how secondary alcohols react with phosphorus trihalides. And lastly, I'm going to show the mechanism of how tertiary alcohols react with the sulfonyl dihalide in presence of a pyridine. So the mechanism is still similar and the products are going to be similar. So in this case, we shall have SOX2 in presence of a pyridine. We shall form an alkyl halide and this as our product. So therefore, let us see how this tertiary alcohol is going to react. So now, just like we saw in the previous mechanism, the lone pairs of electrons from this oxygen attack the sulfur, and one of the chlorine will break off, and it will give us this intermediate CH3OH with a plus on the oxygen. Again, the pyridine base attacks, comes for the hydrogen, and this bond breaks off in favor of the oxygen, and we shall form a very stable carbocation on this carbon. So now, since this is a stable tertiary carbocation, it can stand on its own than the ones we've been seeing in primary. So therefore, this is when the chloride ion, the one that broke off, attacks this carbon and then forms our major product as CH3, Cl. So this will be our major product, which is 2-chloro-2-methyl-propane. So therefore, thank you very much for watching. See you next time as we discuss further reactions of alcohols. Bye for now.